Hello again, everybody, and we've made it to Unit 2, and so we're gonna continue to go deeper into some topics. I think we scratched the surface on functions, but we haven't talked about modules. So let's get right into it. So we're going to develop programs using functions. Using functions in programs. So it is really important to learn how to use functions to your advantage when programming. It allows for your programs to be readable, portable, reusable, and less buggy. And I can go that is very very important to know. Okay, example: write a program that asks the user to enter any positive integer greater than zero. The program should then output the following: the sum of the first n even integers, the sum of the first n odd integers. Ask the user to try again and loop until they want to end the program. So think about modularity. What functions could we write for this program? So let's think about the problem again. So we want a program that asks the user to enter any positive integer greater than zero, and it's going to output two things: the sum of the first n even integers. So let's say the user put in 10, then we want the even numbers between 0 and 10, which would be 2, 4, 6, 8, and I guess 10 included. Okay, and we want the sum of those numbers. And then obviously for the other one we want to do the odd numbers. So what functions could we write for this program? So pause here and think for yourself. We got two different things that we want to do here. Perhaps we need two functions. So just think about it. Okay. Okay. So three functions. So there are three functions reasonable that could be written for this program. When you write these functions, concentrate on the arguments to be passed in and what, if anything, will be returned by the function to the main program. So here are the three functions that we can define. We call this one sum even. So the sum of the even numbers, and it takes an argument, and the argument's variable is n. So it says returns the sum of the first n even integers, and then we have sum odd returns the sum of the first n odd integers. Get positive integer returns a positive integer greater than zero entered by the user. So we can also put that into a function as well. So think about the approach. What code will you write first? What order will you do things? Right? We have to think about it logically, in a sequential manner, right? Because that's how our code is going to execute sequentially. So, writing and testing the functions first would be an excellent approach, as these three functions should be completely independent from the main program. So, what that means is that we can focus on these three functions in isolation. We don't need to think about the whole problem, but we know that we have three different things we need to do. We need to get user input. We need to sum first n even integers and sum first n odd integers, right? Together these three things are making, hypothetically, are creating some sort of useful program for the user, right? But we can think about these functions in isolation. And matter of fact, if you're working at a job, you just might be tasked with just writing one function, one or a couple functions, right? But the functions are a part of a whole system, a software, right? An app, right? So so thinking about things in this way allows us to really it kind of allows us, if we're working on a team, like say if we were working on a team and we have three developers, I could say, okay, you do the input one, I'll do the sum of the even numbers, and you can do the sum of the odd numbers, and we can put that together and make a program that does some useful creative stuff. Okay. So you can write the functions, test them thoroughly, and then focus on the main program. Okay, so let's write these functions now. Okay, so let's go into some code then. Okay. Okay. It wants me to update my shell. Okay. Hopefully this doesn't take long. Okay, it didn't take long. Okay. So let's go into my workspace. Right. ls. We want to go into ICS for you Python. Okay. Now what do we have in here? We have unit 1. Okay, so I need to make another directory. So I'll do this command, make dir unit 2. Actually, what I could have done, so what I can do, let me remove that. So it's not there anymore. I can do this. I can do this command, and then I can do another command right after. CD. I wanna go into that directory, and then I want to create a file called what should we call this? What should we call this? Like, what are we trying to do here? Okay. I'll just give it a simple name. Sums.py. Okay. Okay, so let's see. There it is. So the file's right there. So this is a whole nother. This is outside of the scope of this class, but what I did here was I made a directory called Unit 2. Then I navigated to that directory, and then I created a file in that directory. So once I do this, once I run this command code, it'll open up VS Code. Sorry, excuse me. I'm just my allergies are really acting up. So it'll access. It'll open up VS Code, and you see the sums.py file that I created is there. It exists. So these are just some fun tools they can use. Okay, so let's again go to the problem. So we want 3 functions. So we have fsum even, and then I'll put pass here for now. Def get, what was it called? Get positive int. And I also want you to notice notice how I'm naming these functions. If it's 2 words, I use an underscore in between them. That's how we do it in Python. Now, some of you in your assignment, your formative assignment, did something like this. Like you did camel case, where it was get positive int, something like that, and that's fine. But for this class, I want us to use this because this is what Python kind of recommends. Like this, that's their kind of style guide. And every different companies that you'll go to have their own style guides and stuff like that. And I know I didn't, and I'm not gonna penalize you guys for it until I put out my official style guide that you guys have to follow. Then you'd lose marks if you don't follow the style. Okay. but so far we haven't talked about style in any kind of meaningful way, so that's fine. Okay, so I just want to write comments. Um, get the sum. Sorry, return the sum of the first n even integers. Return the sum of the first n odd integers. And then get get a positive int greater than 0 from the user. So let's actually start with this one. And so we can simply return so we want to get user input, so we'll do sorry, input's a keyword, so I can use user input equals int input give me a number greater, I can put the greater than sign, greater than 0, or I'll just write greater than 0, and then return that. Okay, so we're writing functions here, just to be clear. These are functions. Remember, the keyword def denotes that. Okay, so let's do even. There's several ways we can do this. There's probably clever ways we can do this. I'm just gonna do the simplest way that comes to mind. So so for I in range n, oops, it's expecting colon. Sorry, I want to declare a variable sum equals 0. So we want to say if n mod 2 equals 0. What this is saying is that when we divide the number n by 2, if the remainder is 0, that means that it's an even number. Then we want to say sum plus equals I. Yes. And return sum. So I think that's right. It could be wrong, but we'll always go back and see. Okay. And now it's just the opposite logic. So for I in range n, if, now pause and think what the condition should be. Okay, now think about it. If n mod 2 is not equal to 0, oops, sum plus equals I, right? Return sum. Okay, so we've written these functions. Now we'll stop here and we'll continue. Um, yes. So with all the functions written and fully tested, we can now think about the main program. This is where we can piece it all together. So we haven't tested it. Um, we technically haven't really tested it. Perhaps we should do that. Okay. So I can say I can print some even, and then I'll put in 10 there. Now let's see. Oh, syntax error. Where? What's going on? Sum plus equals I. Okay, so I can't do that. Why can't I do that? I is not defined. Let me see. Line 1. Name I is not defined. Did you mean ID? Um, huh. Not defined. I exists in this scope. Let me try again. Still getting an error. Okay, so this is why you test. Okay, well, let's try some odd. Let's see. Sometimes you make such a silly mistake. So some odd works. Well, it doesn't work, but it gives me 0. Why? Sum equals 0 if n mod 2. Oh, not n mod 2. It should be I. I. Right? Because we want to we want to check every number between yeah, from 0 to n, and I is what's going to be tracking that. So let's try again. 25. So let's see. So what's the sum of the odd numbers from let's see. We have the odd numbers between 1 and 10. So we have 1 plus 3 plus 5 plus 7 plus 9. So we have 4 plus 5 is 9 plus 7 16 plus 9 25. Okay, so it works. So does the even one work? Let's see. 2 plus 4 plus 6 plus 8 plus 10. 6, 12, 20. Okay, it doesn't include 10. So we got to specify. Do we need to include 10? We got to look at the requirements again, because little things like that. Little things like that are important. The sum of the first n even integers. Okay, so it should include the last number. Wait. So let's see. how can we fix that? We can say, what if we do n plus 1? No. Well, that could work. N plus 1. N plus 1. Would that change our answer here? So the even one gives us 30, the odd one gives us 25. What if it's 11? If it's 11, I'm not including the last number for the odds, right? Okay, I am, I think. Let me see. For the odd numbers, it's 1 plus 3 plus 5 plus 7 plus 9 plus 11. Yeah. So we know up until here it was 25. 25 plus 11, 36. Okay. Okay, so it's working. So all I needed to do was increase our index, our range, by 1 so that it includes actually the last number that we want to look at. Okay. And so we can, and then we can test the last function. So I can put get positive here. Okay, and let's see. Give me a number greater than 0. I'll get 10, and then I'll do 11. Okay, so it's working. So we tested the functions, and they are working. Okay, so main program algorithm: get a value n from the user and ensure that n is an integer greater than 0. Print the sum of the first n even integers and print the sum of the first n odd integers. Ask the user if they want to try again and loop until they indicate that they want to quit. Okay. So it says, let's write the main program now using the functions we just wrote. So let's revisit our order of doing things. We looked at the text of the problem and thought about the 3 reasonable functions to write. We then wrote those functions. And tested them. Then we constructed an algorithm for the main program and finally wrote and tested the algorithm. Questions to think about. What if we started with the algorithm for the main program first? How could that have helped us? Okay, so let's keep that in the back of our mind. So let's set out to do what we're supposed to do. Okay, so let's write the main program. Okay. So I'll just write the usage down here. So what did it want us to do? Ask the user if they want to try again. So and loop until they indicate they want to quit. Okay. Okay. So what do I want to do? While okay, we can call this. We can make a variable called selection, and or a boolean. Sorry. Yeah, we call it. We'll make the boolean. We'll make a boolean called selection, and we'll set it to true. Okay. So while selection, sorry, we want to ask the user for the input. So we want to get positive int. We want to call that function. Then we want to, well, once we've done that, we want to print. Um, we want to print out the sums. Okay, so let's put in number and then some number. Okay, and then if, huh, and then we want to print a message. Actually, we want to take input. Input, output, choice equals input, and then our message we want to say is, if you would like to, would you like to continue, yes or no? Okay, yeah. Would you like to continue? Type yes or no. If choice equals n, selection equals false. Okay, let's see what we got going here. Give me a number greater than 0, 10. There we go. So let's see. Let's run it. So here, I gave the number 10. It gave me the two answers. Then it asked me, would you like to continue? And I typed N and it exited. So let's see if I type yes. Delta 5, Y, 18, Y, 100. No. Okay. So it's working. So you see, if we didn't write the functions, then we'd have to write all of this code inside here, right? Now you might be asking, well, what's really, so what? We put these things in functions. So what? Who cares, right? It doesn't matter. I can do the same thing. I can just write the logic for that inside here. But the problem you're solving is this, is that when you're writing a bigger piece of software and you have to use this, you have to calculate this sum several different times. You have to do this several different times. You repeat this several different times. Then you'd have to copy and paste this every single time. But when you put it in a function, all you got to do is call the function, pass in the parameters, and it returns whatever it's supposed to return. So remember, we said that in the beginning. Um, it allows for your programs to be readable, portable. So portable is one thing we haven't really talked about. Reusable, that's what we're talking about here. We can reuse those functions, right? Portable would mean that we can use these functions actually in another file altogether. And that's something that we'll be uh, following up with in, modules. Okay, so So questions to think. What if we started with the algorithm for the main program first? How could that have helped us? Okay. Calculator program. Uh, Start with the algorithm to begin thinking about possible functions. There are at least four to begin with. There may be more as you start designing the functions themselves. So print the calculator options. Okay, so we want option one. Ask which option the user wants and check to ensure that they chose a proper option. If the option is five, then quit the program and print a goodbye message. If the option is not five, then ask the user for two numbers, check that the user actually enters numbers, do the calculation. This approach to building an algorithm is often referred to as functional decomposition. Okay, so what are we doing for time here? I don't want to make this video too long. Um, yeah, perhaps. Okay, you know what? Let's just power through this. Okay. Um, Actually, I want to make the file in a different way. I want to touch, call it calculator dot py, and you'll see here on the left hand side, you'll see it pop up there. There it is. Okay. So we need to functionally decompose this problem, right? We have four operations at least: add, subtract, multiply, divide. We want the ability to ask questions. Okay. Um, okay. So let's do that real quick. Okay. So def add, and then we'll just have two numbers, x and y. Um, Return x plus y. Def subtract return x minus y. Def multiply return x times y, and def divide return x divided by y. And then we want def get num, I'll call it, and hmm this is a new problem. We need to return two numbers. Can we do that? I think there's a way to do that. Um, we'll we won't make a function for that, just to make our lives a little bit simpler. So what do we want to do? We want to do this. So print option one add, and then we want a new line. Option, so we want no space there. Option two subtract, new line. Option three multiply. Option four divide. Option five quit. Okay. Okay, let's just run it and see what we get. Okay. Option one, add. Option two, subtract. Okay. So this backslash n is called an escape character. That's what gives us the new line. Just so that's why I put it there. Okay. So we have here. So okay. So now we've printed out the options. Perhaps we want to put it in a loop actually. So for no while choice okay while choice and choice equals true. Print out the options and then so we'll have some if statements. Maybe I should put this actually in an input statement. So if selection equals the character one, then okay, we want to get to okay, call X. We need two numbers. Give me the first number. And then give me the second number. And then we just call add X Y. No. We want to print it. We want to see what's going on. We want to print X plus Y equals %D okay. Let's see what that does for us. Oops. Okay. 2, 3, 4, 5. Okay. Okay, let's see if this logic here may be wrong, my syntax, but we got to test it. Uh, oops. Huh. Oh, there's a problem here. 2, 4. Okay. So there's a problem. Okay. I hope you guys see the problem. And then I'll do a new line. Yeah, new line. So I'm asking for the options. So the user is going to put in their option. If they want to quit, okay. So I shouldn't be asking them for the So okay. Okay. Um, actually, what did I do? Let me. Let me cut this. Okay. Okay. So we wanted to say if selection is not 5. No. Yeah, if it's not 5. So okay, we want to nest. I want to say if selection is not equal to 5. Um, and then this should be else. Okay, let's see. So if I type 5, it should exit. Okay, there we go. So let's do add. Give me the first number. 3, 4. Huh. Oh. So okay. Okay, so this is just some troubleshooting. I know this video is kind of getting long, but let's see. Okay, so we present them with the options, and then we choose an option. If it's not a five, oh, okay. Let's see if that changes things. Actually, okay, three. Oops, I'm making mistakes here. Okay, let's try again. Um, Sorry, I gotta click down here. 3, 4. 3 plus 4 equals 7. I don't need this. Three, 4. I should just. Okay, let's try one more time. Okay. All right, so. Just some formatting here. And okay. Oh. Okay, I'm forgetting the F for format string. Okay, so the program works. Let me just quit this. So the program works. Okay, print a goodbye message. Okay, well. Okay, so yeah, that's it. Before going on too long, yeah, that's it. So if you have any questions, feel free to ask, and we'll see you in the next one.